for our final session, or final talk for this session, Eric Bohm is going to talk about recent updates in Charm++, I think is the name. Eric is a longtime research scientist in the Parallel Programming Lab.
Hello. Thank you for your attention. So for the last talk of the day, since I'm what's between you and the banquet, I'm going to try to make this a little interactive. Every slide has at least one question on it, to which I'm happy to take answers. We can take some notes and think about it, as that's more or less we're moving forward with what we've been doing recently in Charm, and we're welcoming your feedback as to if this matches things you need, or if there's more important priorities in the spaces for each of these slides that we should be focusing on. So to start with, one of the things we've integrated is, goes by a few different names, but basically it is designed to minimize the overhead of copying when doing message transactions. And so the direct API has now been integrated and is going to be in the next release of Charm. And Nitin is going to have a talk tomorrow, which gives you the details. But here I wanted to sort of highlight a few of the fundamental issues, is that we're providing essentially a few ways to access memory. And fundamentally, in most cases, people are focusing on get semantics, because in many cases, they have an ability in their application to know when the remote data is available, as opposed to knowing when it is safe to write to remote memory. And in that case, the actual completion detection from the underlying RDMA technology works well for the get-based scheme, in that your initiator is the same as the target. So it's fairly straightforward for us to tell you when your data has arrived. And we can provide a nice low latency approach for this with no copy semantics on top of your operation from Charm or from the message layer, just directly from your buffer. However, in order for this to work, your buffers need to be known to be in memory. They need to be registered or pinned or operating on a machine where there is no problem with the virtual pages being paged out or swapped out. In order for us to access a piece of remote memory, it needs to actually be there. And so that comes down to memory registration, for which we have a few strategies I'm going to talk about on the next slide. And the question here basically is, right now, all of this is implemented, and it's fundamentally about messaging, cross node-to-node messaging. However, as we look at the way that GPUs are operating, and if you're going to do a memory transaction from one GPU to another, should we look at extending at this existing semantic to address that, or should that be handled by some other mechanism? It's kind of an open question. Pure sort of research, like up in the air.
So would that data transfer require
As long as those two GPUs are in the same host, CUDA will do that effectively. But if those two GPUs are not on the same host, it can't. And so, but it too has the same fundamental challenges in order to do these operations, that the memory has to be there. So it's one of those things that we need to think about more, I think. So moving on to the registration. Oh, yeah, sure.
I mean, so one issue with that is that, pinned memory becomes a scarce resource. Mm-hmm. And this is already an issue, at least with Django, for the message passing layer, right? Say the InfiniBand needs to allocate all these message buffers, and then you got to allocate some more buffers for the GPU, and a lot of times you don't run out of memory, you run out of
pinned memory.
Or the pin slots, I think. Whatever the OS limit. So there's this general issue of managing that kind of memory. I don't have a solution, but I'm just telling you it's a problem.
That's why I think a convergence between these two is probably necessary, because
Right,
they both
yeah,
have
yeah.
to fight for the same resource. They need it for exactly the same reasons.
Yes.
Which is why I bring this up here. So for registration itself, we've looked at a few different ways to handle this. And the top one is the one that gets you the biggest bang for your buck. And basically, if you want to do direct, no overhead read and writes from a buffer in your application space, if you allocate it using CK RDMA alloc, we know it's pinned because CK RDMA alloc pins it. And so if you then want to do a one-sided operation on it, we know it's perfectly safe. We can do that one-sided operation and get you the best possible benefit. However, that memory is now basically pinned. And so you better be pretty sure you're going to reuse that frequently to get the big bang for the buck from that. The next possibility is you don't guarantee that your buffer is pinned, and so the mode of the operation you're going to perform is the unregistered mode, and you rely on the runtime system to do that registration for you before it triggers the operation. And so this will almost certainly incur per transaction registration overhead, and on some conditions may also incur some additional copy overhead and some message transaction overhead in addition, ahead of the operation, increasing the latency. The third one is to request that the direct API just register your buffers for you. Rather than registering them, unregister them behind the scenes, it would just register them and leave them registered. And that works okay, but there's a first-time transaction cost for that. And then finally, the no-reg scheme is more or less included here for completeness. This is what happens when we are actually running this API on infrastructure that doesn't actually support RDMA, is that we don't actually do registration on like an Ethernet, for example. And so in this case, you would not assume that RDMA is happening because there's no pinning. Any feedback on this? It is a little clunky, but we haven't come up with a better solution to this.
Can I use this inside like a STID vector? Let's say I pass it.
Allocate. If I wanted to say use a STID vector and I just pass it an allocator that wraps those, would that do the right thing? As in, because that would be something really nice to have.
It should work because this is just giving you a contiguous buffer that gets pinned.
Okay, thank you.
So what happens on failure? I mean, speaking of limited resources, would you fail over to unregistered or?
If you are initiating the one-sided operation, I think Nitin right now it would fail, right? If you can't pin.
Yes, so that's why I think, so you're saying that when you're trying to register and there isn't. So you're basically talking about the case where there isn't any more memory that is left to register, like the pinned slots have been taken? Yes, in this case, in the current case, it fails. So because there's nothing as such that we can do. The only way we can have more registered slots is if we intelligently deregister, which is what we do in some cases. Once we are planning to have a registration cache in the future where we see that if there is a particular buffer which is not used, the runtime can deregister it. And right now in this particular API itself, if the user can see that a particular buffer is not being used anymore and the transaction is complete, the user can specify calls to deregister it too. So those are the modes of deregistration available. But at registration, if there isn't any more memory available, it fails as of now.
This CK RDMA alloc, is that coming from a pooled registered memory?
Yes.
So each call is not exhausting one slot. So So it's unlikely to fail like that.
Yeah.
Yeah. And I think we should reserve some of these questions for tomorrow, after tomorrow's talk, but let's finish this one.
So, okay, so it's pooled, and you can deallocate inside of a slotted page inside of that pool, but how do you handle fragmentation, right? Because you can't compact pinned memory. So you could, yeah, so I guess you just have to exhaust at that point, right?
I don't think the RDMA locked one can be deregistered. But anyway, why don't we talk about that offline? Yeah. Okay. I think we move forward. We can discuss this. It's a little technical, and we are late. So tomorrow he's giving a talk anyways, so we can talk about these issues tomorrow.
All right, I can move on to other equally contentious but different topics. So another change we have is we've introduced some command line options to replace the PE map, com map, as I would say they are not well liked by people who have used them. They're better than no control over binding, but they are awkward. And so we have a whole suite of new approaches, which basically have this look of you choose like how many processes you want per socket and how many worker threads you want per socket, or how many worker threads you want per core. And we actually use HW lock to examine the actual platform and provide that kind of pinning. And that's more or less what people have been manually doing with their PE map, com map anyway. And the other thing here is auto provision, which basically just tries to use everything that's available on each node. Which is good for small scale, simple invocations, or even potentially at large scale. Question here is, they're sort of twofold. One is right now, the default, if you don't provide any arguments, is that you get one process with one worker thread, much like MPI does. Is that the right answer?
One process per physical node.
No, if you provide no arguments,
One
you just
process
get
per
one
core.
process on the 0th node, right? Is that the right answer? I don't know. We should. It's worth some discussion. Follow up an email probably on that. And if there are other command line issues from Charm Run and running Charm applications that are causing people grief, we'd like to hear about them so that we can reduce the friction.
So one quick comment: auto provision is everything we can see is ours, yes, but it also is making some intelligent choices about creating a process per socket or whatever it knows about the machine. It can bring that intelligence to bear to say, oh, let me create 4 processes per node and then use one, not use SMT or use SMT. It's making those choices for you intelligently, or the intelligence will improve over time, but let's assume intelligently.
I had issues with CharmC not handling quotations and arguments correctly and forwarding them to the compiler. It would strip the quotations, and then I could not use the same arguments to the compiler and to CharmC, because we compile by just invoking the compiler, and we link with CharmC. So that's something that caused us a lot of grief, and I can't remember what the workaround was, but yeah.
Yeah, CharmC is a continual, has the same kind of challenges as CharmXI in many ways, but.
Right.
So one thing with this issue that would be very useful as an application developer is the ability to provide, a function that can provide guidance to the runtime as to what my application specifically would prefer. So some applications, may have, much higher communication demands than others. So if I could have a function that could set some preferences or somehow ingest information from the runtime and make a decision maybe, based on, the application-specific command line arguments or, whatever other information it can grok, that might be a little bit better than trying to do the right thing for,
Yeah, there is no one right answer
the
for all
assumed average application. But yeah, being able to say, hey, So at runtime, this is my set of preferences for what to do in the various common situations. You figure out what the machine looks like and apply these rules rather than applying your own rules.
Okay, yeah, that's good feedback. All right. A lot of other work recently. Oh, sorry, go ahead.
I have a couple of things. I want to go back into, what was it, auto provision? And Sanjay, when you said you see the machine, does that mean the machine or the cycle times the scheduler gave you? What do you mean? Is it the
when you say
allocation or the machine, or is it the hardware or the allocation that I have?
Hardware.
Okay,
what
so
type of nodes do you have? What type of physical topology? Like how many sockets?
That's hardware then. And so, do you guys under auto provision? I understand that's machine, but then how does that interact with the scheduler? Is it can I assume
okay, here is a simple rule. Number of nodes is given to you by the scheduler, and how to configure stuff inside a node is what this is talking about.
I see.
Right?
Okay. Thank you.
So on each physical node, how many processes to make and how many threads to make inside each process is what we're talking about here.
Okay,
It will
so
also
nothing.
to set launch number of processes. But
One other note is that the auto provision is currently only implemented for the Ethernet and InfiniBand verbs network layers, so it may not apply in terms of a formal scheduler setup.
Okay.
But given a node list, it launches.
Okay, another thing that just came to my mind because of the RDMA stuff, which probably has nothing to do with that, but I was wondering if there is a way to, in a broadcast fashion, call the destructor for a chart array or group. I know for a single element I can always delete it, and then that calls the destructor eventually. So I want to get rid of a class because I don't need it.
Yeah,
is there a way to I just don't want this whole array?
It is not an entirely solved problem. There has been some work studying the best way to do that safely.
Oh, that's not even that simple as I may be thinking.
And yeah, it's harder than you think. Because what if a broadcast is in progress already on that char array?
You were right, yes. That's true. So if I want to do something close, then maybe I run a loop over the whole array that I know.
I don't see a problem. Broadcasts are sequenced by their epoch number, so it should be possible to send a destroy yourselves broadcast to the char array in the user space. And that works, and so why not in the system space? I think it should be doable. We should consider it in the next. Yes, Eric.
I don't remember the name of the function, but I think CK destroy.
Yeah, CK destroy should do that. And there's a Redmine issue which Phil was working on, which describes some of the complexities of making it do exactly what people want.
Yes. Okay.
Yeah.
Okay. All right. Move on to next. How many do we have more? I think I want to put a time limit so that they can stop and we can. Okay. But anyway, go ahead. Yep.
So the offload API right now is.
So this may be one for tomorrow.
Integrated. Pardon?
Right? This may be one for tomorrow because there is a talk on this tomorrow.
Yeah. But basically, people should think about what other aspects of accelerated interaction we should prioritize, because it focuses just on offloading the work queue, basically. And how much priority we should place on other accelerated APIs, the kinds of things we would like some feedback on. C++ integration, recent work based on feedback from people who have been focusing at the bleeding edge of our C++ support. We've improved support for reductions on vectors, support for inline, support for R-value references, wider proper support of pup across more interesting data structures, and CK loop now supports Lambda syntax. And we would like to hear feedback of basically the sort of other hot list of C++ features that we should be focusing on. Variadic templates.
I talked to Evan about that already. He might already have a patch ready. So.
Okay. And yeah, send us email, Redmine issues, so forth. Just we're looking for feedback. CharmPy, you heard us talk on that, and it provides basic Charm++ support. There's some things it doesn't have and some limitations, but we'd like to hear basically which parts of the Python ecosystem we should prioritize to verify that our CharmPy does what people would like it to do, that it works in the context that people care about, and basically these are use cases for CharmPy that deliver a convincing argument that it's ready. What is the delta between what we have now and the production version of CharmPy? We don't really have a good way to measure that right now. Within Parallelism, there's been a fair amount of work, and so recently we've integrated boost threads, which we call UF context threads. They're the default choice where they are not known to break things, which is basically OS X. And so they improve threading performance because they have really good context switching and a number of other benefits. We've integrated the LLVM OpenMP implementation so that we can actually interoperate nicely with OpenMP pragmas and our own threads and CK loop operations. We've implemented finer controls for CK loop work streaming strategies and controls over which actual PEs are doing work stealing if you want to rule some of them out because they're busy doing something else. And one notable issue is that our current support for OpenMP Task API and its tree of things is fairly weak, and we're curious how high a priority people feel that should be.
Or even more broadly, the usage mode in which some people asked about. Our OpenMP is every core is still running a PE, still has chars, and they're firing OpenMP only to kind of smooth out load imbalances. Otherwise, every PE will do its own iterations. Alternate model is for us to have only one charm PE on a process, but still have lots of drone cores, and those drone cores will be running OpenMP. Do you like that model? Do you see a use of that model, which is like the standard MPI plus X like model? You can do that model now with some. Okay, there are two ways of doing that model now. I mean, one is you can just fire with the right PPN but then the core control, you have to hope that OpenMP is doing the right thing with that. With the right mask, you can probably do it. But then you're using the vendor OpenMP, and maybe you want to use our OpenMP. But I don't think in that situation there is much of an advantage to our OpenMP. So you're right. But that mode of usage, I don't know if it is common. Do people use this? Just fire off a bunch of use PPN1 and then use OpenMP, regular OpenMP inside. Anyone does that? So that would be another point of feedback if you want to try that and so on, as well as the specific questions that Eric asked here. Task API.
Is there any support in this for the OpenMP4 user-defined reductions?
Sunmyang?
So OpenMP reduction is separated as they are in the just standard OpenMP. So you can use OpenMP reduction on the integrated runtime.
But what about user-defined reductions?
OpenMP user-defined reduction?
Should work as it is.
Yeah, I think it should work.
Yeah, the OpenMP implementation, I don't know if for us clear or not, it's riding on top of LLVM's OpenMP implementation. We just use a team consisting of user-level threads and steal those user-level threads. So it will do pretty much everything.
Are you parsing the pragmas themselves, or do you just intercept?
So all the pragmas are parsed by the compiler. So I just changed the runtime.
Okay.
So yeah, all the clauses and pragmas on OpenMP standard works.
Okay.
All right. AMPI, a bunch of point features are included in the new release. We're improving its performance. We've updated how AMPI migrate works to provide clearer flexibility in what it's supposed to do, how well it works with load balancer, and we've improved performance and support for a variety of MPI calls. We've also improved support for TLS globals and minimized AMPI's interaction with other MPI choices as much as possible, and improved support for compiling with MPIF, and added profiling support, and added an AMPI run wrapper script that works much like Charm Run to simplify launch. So we're soliciting feedback of basically what else in MPI3 that where you know that we have some shortfall, are you interested in us focusing our efforts?
How many people here have used AMPI other than PPL students? A little bit, okay, yep. So I think this AMPI feedback would be very useful afterwards if you go ask your friends and others, send us feedback, because I think AMPI is becoming important to us and is becoming more production quality, and so that would be one way of getting a wider user base to use the Charm runtime system.
And finally, this list of questions basically is a launching point for basically longer term discussion. We aren't going to be able to cover all of these here. But essentially, we're looking at post 6.9, which is the next release. We might have the release after that be Charm 7. Major version release, break APIs, rearrange the world, right? Potentially, at least the world of Charm. So. And so here's some questions, basically. How attached are you to the current load balancing API? We're thinking maybe we'll just throw that away and put a new one in that was talked about earlier today. Should that be focused on sort of global load balancing the way it is now, or should we change the way that it works and focus it more on cross-host load balancing and worry about within node by a different mechanism? Should chars be bound to a execution thread by default? That's how things are now. But if we make the ability for chars to be unbound, should that be the default? Or should that be a special kind of char people choose to make? Should entry methods be non-reentrant? Right now, I like them to be the assumption that they aren't reentrant, because that makes debugging a whole lot easier. But maybe there are conditions under which we should think about how we do our reentrancy semantics. How much of a burden is CharmXI? For several of you, I know the answer is a lot. For other people, it's smaller. And so we've had excellent feedback of places where CharmXI is causing grief. So more detailed feedback would be helpful as we are looking at different ways to allow people to use our runtime system without having to use CharmXI. And we welcome feedback there. Furthermore, right now, there's this sort of assumption that there's a one-to-one relationship between schedulers and execution threads and hardware threads. Is that the right relationship for the future with these very wide nodes? Should we have only a couple of schedulers per physical node and have a bunch of cores be dumber? They don't have their own scheduler. They do work stealing, or all of their work is dedicated to them by other schedulers. Should we implement multiple COM threads per process? Or should we try to make everything work the way PAM-AL RTS works, where it doesn't really have COM threads? It uses different mechanisms to address these issues. These are all potentially highly intrusive if implemented, or a lot of work. So there's sort of a question basically of how we should prioritize these kinds of things for the next big Charm release.
So for the last one on communication threads, I assume the reason that the PAMI layer can dispense with communication threads is that under the PAMI library that it's calling is highly tolerant of being called from multiple threads simultaneously and is highly reentrant. For other communication libraries, that may or may not be the case. I know there is work on MPI to make MPI thread multiple actually performant, but again, that's going to depend on what's below that. And so,
and we also, the kinds of things that we want to do help drive interactions with vendors, like Intel's implementation of OFI, for example. They are talking about being properly, fully reentrant in their usage, much the way that PAMI is, and may be there. It's a question of exploration at this point.
Yeah, I mean, so it would be nice to make that, a switch that you can throw so that, you write your alerts layer, and the alerts layer can be, the same alerts implementation of the machine layer could be called with a COM thread or without a COM thread, and with multiple, basically reentrantly, and you only have one version of that implementation. But say the actual, then you pick which is more performant. Maybe you don't want to give up that core. Maybe you try it both ways and you see what works. I also wanted to just note, I gave a talk a couple of years ago with various suggestions along these lines. So.
Oh yeah.
I don't think
I didn't invent these questions. Some of them came from you.
Yeah, I haven't had any better ideas since then. So.
Okay, the very last question, then we stop.
I'm voting for multiple COM threads per process, because frequently I run. And it depends on the network interconnect. Like the Stampede KNL, the communication is very compute heavy, and so I need multiple processes per node just so I can get the COM threads that I need. But it'd be more efficient if I had a single process with.
Although we'd have to have. Reentrancy and contention control between our COM threads. So.
I mean, yeah, I know it ain't easy. Yeah.
I mean, there's a trade-off between costs there. All right, thank you very much for being very patient. You have stayed till 6 o'clock here, and thank you guys for taking care of us all this time. Once again, thanks.
Oh yeah, thank you.